All right, so we're going to find the slope of this equation. 3 times x squared plus y squared all to the second power equal to 100xy, and we're going to find it at this point 3, 1. Now, this is an example of an equation that can't be defined explicitly, so it can't be defined in terms of just y or just x. It won't be a function of, like it won't be like written out as f of x exactly. And if if we look at a little sketch of the graph, you're going to see that it looks like what's called like a lemniscate. So we're looking at the slope of this graph at about right here, like about 3, 1. Okay, so for this, we're going to have to use implicit differentiation. And what that involves is that we're basically like going to use chain rule a lot. And we're going to basically going to use it to differentiate the equation with respect to x still, but each time we differentiate y, we have to make sure we multiply it by dy over dx. And then we're going to solve for dy over dx and evaluate the final equation at this point. So let me just go through it so you can see what I mean. So first, let's go to the algebra. So let's expand this, write this out as a binomial because it'll be easier to work with. So let's rewrite this as 3 times x squared plus y squared all to the second power. So this would then be x squared times x squared, x to the 4th, plus x squared times y squared plus x squared times y squared. So you get a plus 2x squared y squared plus a y squared times a y squared. So plus a y to the 4th. And let's subtract this 100xy and bring it to the left because it'll actually help us later on. So minus 100xy, and that'll be equal to 0 then. And let's go ahead, let's distribute this 3 right now. So we'll get 3 x to the 4th plus 6x squared y squared plus 3y to the 4th minus 100xy. Now, always check your algebra work at the beginning because it can screw you up down the road. It has done this to me a couple of times, unfortunately. All right, now let's go ahead and start differentiating. So we differentiate the x terms like usual. Like it's not really going to be any different than what we're used to. So what I mean is like we take the derivative. So using power rule, 4 times 3 will be 12x to the 3rd plus. Now here we actually have product rule. Remember, we have basically an f times g. Like think of this as like your f, and that's your g. And let me write the product rule again. If we're gonna find the derivative of f times g, remember we're gonna have to take the derivative of f multiplied by g, then add it to f times the derivative of g. There's a little refresher. So again, let's just factor out the 6 for now because it'll make it easier at the end. We'll multiply it by 6 at the end. So first take the derivative of x squared, which is 2x, and then multiply it just by y squared, so times y squared. Then add this to x squared plus the derivative of y squared, plus that's our g, so plus x squared times 2y. But here, we're going to need to multiply it by dy over dx because we want to look at this in terms of x. We're differentiating with respect to x. So every time you differentiate a term with y, multiply by dy over dx. Now we're going to add it to the derivative of 3y squared, so plus the derivative of 3y squared. So treat it just like the power rule, so 4 times 3, so plus 12x cubed. But again, multiply this by dy over dx. So that'll be that, multiplied by dy over dx, minus 100. And here we again have a product rule. We have our x times y, one function times another one. So we're gonna use product rule here, but let's factor out the 100 again. And then first, it'll make it easier later on. So the derivative of x, we just treat it like a constant. It'll just be 1 multiplied by y plus x times the derivative of y, which is just 1. But now again, we multiply it by dy over dx. And then is equal to the derivative of 0, which is just 0. So that's not an issue. All right, cool. So this is like the calculus part. These next steps are really solving for dy over dx. And you want to think of dy over dx as just like a term. Like think of it as just like you're like factoring out like a z or like, you know, like some variable. There's just some term. So you can in a sense use, you know, division, multiplication, that sort of thing. But let's go ahead and what we're gonna do is let's see what will make sense. Let's first clean this up a little bit. Let's expand this, multiply each of these correctly by 6. So let's have 12x cubed plus 6 times 2xy squared, so plus 12xy squared plus 6 times this, so 6 times 2 plus 12x squared y dy over dx plus a 12y cubed times a dy over dx, we can just say, minus 100 times y, so minus 100y, minus 100 times x times dy dx, so minus 100x dy dx. That will be equal to 0. 0 looks kind of weird. All right. Now, see, we want to then just solve for dy over dx. So we want to keep the dy dx terms on one side and everything else on the other. So what we'll do, let's actually bring these 3 terms like to the front, because these can be quite tedious. So let's kind of shorten the work. So let's have dy over dx times this, so times 12x squared y. We're just rearranging right now, so we're bringing that to the front. Then plus 12y cubed, that's our second term. So we're bringing that to the front. And then minus 100x, because we're going to have that there, minus 100x. Let me make sure that I got everything good. All right, cool. Now, let's again save some work. So I'm going to set this equal to, so we moved these 3 terms, we kept them on the left, we just grouped them on one side. And what we could do, again, as long as you're paying attention, this is not an issue. We can go ahead and just subtract the 12x cubed, the 12xy squared, and add the 100y, so they all go to the other side. Because on the other side, see, we have a 0. I could just write it again over and equal to 0, but just again to save some work, let me just do it all like that. So I'm going to cross this out because I'm going to subtract it from the left. So on the right side, we'll have minus 12x cubed. And I mean, then subtract this from the left side. So minus 12xy squared. All right. And then let's go ahead and subtract or add this last term. So we're going to have plus 100y on the right. All right, so stare at that for a second, make sure it makes sense to you. And now we just divide by this whole group in black here. We divide each side by that. X squared y plus a 12y cubed minus 100x. And this will be my equation for dy over dx. All this goes away. So dy dx is equal to this whole thing. All right, so the fun's almost done. We still got one more thing to do. This is our equation. Now we just want to evaluate this derivative at this point. So we want to find the value of this when x is 1 and when y is, or when x is 3, when y is 1. So essentially we're finding dy dx of 3, 1. So all you're doing is plugging in 3 for x and 1 for y and just making sure the math works out nicely. That's really it. So let's see if I can not screw up. So negative 12 times 3 cubed, 3 times 3, 9, 27. I believe that's 12 times. So that'll be a negative 324 minus a 12 times 3, 36, times a 1, so minus is 36, plus 100 times 1, so plus 100, over 12 times x squared, so 12 times 9, so 12 times 9, so 108, I believe, and times 1, and that would just be 108, obviously, plus 12 times 1 cubed, so plus 12, and then minus 100 times 3, so minus 300. And I believe that will simplify to 13 over 9. Which is about 1, which will be repeatingly 1.44 repeating. And that makes sense because it's going to be positively sloped. All right, there you go.